In this question, we have a cruise ship that is sailing due north at 4.5 meters per second. And we have colored a vector in blue here pointing straight up, and that vector shows us that the cruise ship is traveling northward at 4.5 meters per second. So this picture is relatively straightforward. But then we have the patrol boat, which is heading 45 degrees north of west. So that phrase north of west is a little tricky to understand. What it basically means is northwest. So we have drawn a vector that's heading off in the northwest direction. Recall, of course, this is the north direction and this is the west. And the angle given is 45 degrees. But what we need to do is find the x and y components of this velocity vector. And so if we were to draw the x component, it would point in this direction right here. We can call that velocity patrol boat x. And then this vector pointing straight up would be the velocity of the patrol boat y. And again, we need to find those two components. Now, most of us have learned that an x component for a velocity or other vector involves the cosine of an angle. So what we would do is take 5.2 meters per second and multiply it by the cosine of an angle. But where I see students get constantly tripped up is what angle to be using. When you use an angle to find the x component, make sure that you measure your angle in reference to the positive x-axis. So this 45-degree angle is not the correct angle to use. We have to measure our angles when finding components relative to the positive x-axis. So in other words, we want this angle right here. Notice that's a counterclockwise angle, therefore it's going to be positive. In physics and math and other subjects, counterclockwise are positive angles. And so we actually need that angle. Now, most of us know that a straight line is formed here equal to 180 degrees. So we need to take 180 degrees of that straight line and subtract off the 45 degrees. So this will be 180 minus 45, which of course will give us 135 degrees. That's the correct angle that you should be using for your x component as well as your y component. So if we pick up our calculators, make sure they're set to degree mode, and punch this in, we will see that the x component of the velocity is negative 3.68 meters per second. So far, so good. As noted, we also need the y component for the velocity of the patrol boat. So we'll take the 5.2 meters per second and we'll multiply that by the by the sine of the angle. For the y component, you should be using the sine, not the cosine. But you can use the same angle, so it's 135 degrees. So 5.2 times the sine of 135 will give us a y component velocity of 3.68 meters per second. So you can think of the patrol boat as moving in two directions, which of course it actually is doing. It's moving to the west at negative 3.68 meters per second, but simultaneously it's also moving to the north at positive 3.68 meters per second. So that is a little bit more complex than the other vessel, which was the cruise ship, and it was just sort of idling along at 4.5 meters per second. So we'll draw that in again. Here's the cruise ship, and it's going directly north at 4.5 meters per second. Now, let's get the relative velocity. Remember, that's what the question actually wanted. If we go back and take a peek at it, it wants the velocity of the cruise ship relative to the patrol boat. So this phrase relative to the patrol boat is important. You want to perhaps imagine that the patrol boat is actually stationary. So try to imagine a stationary patrol boat. And from the patrol boat's perspective, remember, the patrol boat is, in fact, moving to the left. But we're imagining it's stationary. So what's happening is the cruise ship, which is way out here, we'll say that's a cruise ship. Think of it this way. As the patrol boat moves to the left, the cruise ship is getting closer and closer and closer to the patrol boat. So in essence, you can think of it as if the stationary patrol boat was watching this cruise ship move closer and closer and closer to it. Now, at what rate is this cruise ship moving closer to the patrol boat, well, it's this velocity right here, 3.68 meters per second. So in essence, we can say that the velocity, actually a relative velocity of the cruise ship relative to the patrol boat, is positive 3.68 meters per second. Again, it's because this cruise ship is getting closer and closer and closer to the patrol boat. So from the patrol boat's perspective, the cruise ship is actually moving to the right in essence, and that's why it's going to be positive. So that would be the x component. We'll also need the y component. Let's just draw a line here. Remember, the cruise ship is moving in this direction at 4.5 meters per second. And the patrol boat is also moving northward, but it's moving at a little bit of a slower velocity, only 3.68 meters per second. So again, we have to try to imagine in these relative velocity questions that the patrol boat is actually at rest, even though it's technically moving northward. And if we imagine that, we can imagine that from the patrol boat's perspective, the cruise ship is receding. It's getting further and further and further away from the patrol boat. Now, how fast is the cruise ship receding? Well, it would be the difference between these two velocities. So we can say that the velocity of the cruise ship in the y direction relative to the patrol boat is going to be the difference. So we're going to take 4.5 and subtract off the 3.68. And when we do that, we get 0.823 meters per second. Now, that would be for the y direction. We forgot to label this one as the x direction. So those are the two answers. If it's still a little confusing as to why we're subtracting them, think of it in the opposite sense. Imagine that the cruise ship was going north as it is, but this time that the patrol boat was going southward at 3.68 meters per second. So in that case, they'd be moving apart from one another at a very fast rate. You can imagine one's going north, the other's going south, so they're spreading apart at a relatively fast rate. So in that case, you actually would add those two together to get your answer for that case. But in the case where they're sort of moving in the same direction, while it is true that the cruise ship is gaining or getting ahead of the patrol boat, it's only getting ahead at a rate of 0.823 meters per second because the patrol boat is sort of moving in the same direction.